All right, continuing on with the 2021 AMC 12A Problem 6. A deck of cards has only red cards and black cards. The probability of a randomly chosen card being red is 1/3. So we've only got red and black, so it's like R over red plus black, that's 1/3. When 4 black cards are added to the deck, the probability of choosing red becomes 1/4. So then you can think of it like this actually. Let's just say this is red, right? Red on top and total on the bottom. I kind of don't want to go with this path anymore. So what I'm going to do is say that there's a 1x to 3x ratio between red and total. And that's going to allow me to, instead of adding 4 to this and making it too complicated, we can just say x over 3x plus 4 is going to be 1/4. Gut just kind of says x is 4. I don't know, it's probably some logical reason why my brain's telling me that. But basically, if you were at 1/3 and you added 4 to the bottom and it became 1/4, it makes sense that you had 4 and 12 originally. 4 over 16, 1/4. X is going to equal 4. How many cards were in the deck originally? That would be the 3 times 4 is 12. See you guys in the next one. All right, and now the 2021 AMC 10A Problem 9. Test is starting to get fun now. Also the AMC 12A Problem 7. What is the least possible value of this xy minus 1 squared plus x plus y squared for real numbers x and y? Okay, well, we got a perfect square and a perfect square. Smallest those can be is 0. It's got to be 0. Or is it? Yeah, that looks like a nice right trap answer. Just looking. Do you really think on number 9 you're just going to go, oh, 0 and 0, I'm so good, right? I hope you didn't do that. And if you did, it's okay. We all make mistakes at times. But it's not that hard to expand these. Go ahead and do it, right? So xy squared is going to be x squared y squared. This times 2 is minus 2xy. -1 times -1 is plus 1. This one expanded is x squared plus 2xy plus y squared. Ah, well, look at negative, positive, goodbye xy terms. And then we have what? X squared y squared plus x squared plus y squared plus 1. I wrote the squareds first because now we can actually think about it. The 1 is not in the middle of a square. There's not anything weird going on. We're probably not going to get trapped here. Double check. Real numbers x and y means I could choose 0 if I wanted. And the smallest these can be now, because they don't have anything extra going on. They're just a number. The smallest any squared number can be is really 0, right? But while, yeah, it's not going to work because the values you would have to pick for x, y to make this expression 0 will not make that expression 0. That's why it doesn't work what I tried at the beginning. So I could make them both 0 though. This would be 0 plus 0 plus 0, 1. I cannot get lower than 1. That's the answer. Sorry if you fell for the trap, guys. It happens to the best of us. Let's get on with it. All right, and now we're on to the 2021 AMC 12A Problem 8. A sequence of numbers is defined by d sub 0 is 0, d sub 1 is 0, d sub 2 is 1. So let's get this started. We've got 0, 0, 1, okay? And d sub n is equal to the previous term, which is how you should read this. Don't read it as d sub n minus 1. Yeah, but what does that mean? Let's put it into English for our brain to understand better, right? So the previous term plus the third previous term. So it's kind of like Fibonacci, but not quite, because Fibonacci would be a 2 right here, right? So basically, let's just do it for the next one then. It would be the fourth term is the third, this one here, and then 3 back. So this one, the first previous, and 3 previous is going to be 1 also. And already, before we even, I don't know, I'm just going to list a few of them out. I feel like we're going to need it. So this one would be 1 plus 0 is 1. And then you're going to have 1 plus 1 is 2. And then you're going to have 2 plus 1 is 3. 3 plus 1 is 4, 4 plus 2 is 6, 6 plus 3 is 9, and just keep making them. You're probably going to need a few. So 9 plus 4 is 13, 13 plus 6 is 19, 19 plus 9 is 28, and that's probably good there. It's got a good run. It doesn't take that long to do that, and it's better not to split it up. Like, you want to keep all of the thoughts that are of the same kind at the same point in time. Don't do part of it, come back, and just, yeah, do it all at once. Okay, so, because your brain has to switch gears, and it slows it down. So, what are the parities, evenness and oddness, of the triple of numbers D 2021, 2022, and 2023, where E denotes even and O denotes odd? The answers aren't going to help you. Let's go here. Let's just write what we've got. We've got even, even, odd, 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 even, the 3 being odd, the 4 being even, the 6 being even, the 9 being odd, 13 is odd, 19 is odd, 28 is even. All right, let's look for some kind of like repeated part. Here we go. 2 E's followed by 3 O's, 2 E's. Okay, so where's it going to end? Right here. That's the ending. E, E, O, 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 E, O. Right? Sounds like some kind of song. Anyhow, so we probably just need to make sure that the next one's an O, and then we'll be good. And then maybe an E after that. So if I add these two, of course it's an even plus an odd. It's going to be odd. And then it'll be 41. And then I'm going to have an odd plus an odd, which will be even. And there you go. There's the start of the next cycle. We've got it down now. 2, 3, 4, 5, 6, 7 terms in the repeated portion. So each iteration of 7 terms is going to look just like this. We are looking for 20, 23, 20, 21. Try to find a multiple of 7 right around there. So 2100, for instance, is a multiple of 7. If I take away 70, I will be at 2030. If I take away 7 from that, I will be at 2023, which is this one here. So that would mean I'd be right at the end of the cycle right here, correct? No. No, if you did that, you probably got trapped because it's D sub 0 is the first term. So in fact, the third term in the list is not really D sub 3, it's D sub 2. And so the 2023rd term in the list, which is this one, is not D sub 2023. It's one before that. It's D sub 2022. Okay, because again, you're starting at D sub 0, not D sub 1. So your counting's kind of offset by 1. So again, just a moment to make sure you get that to understand why it's not, this is not D sub 2023. Because the third term has a 2, the second term has a 1, the first term has a 0. So the 2023rd term would be, it would actually be the how do I say that? It's this one, D sub 2022, right? So you have to subtract 1 from what you want. When you say 2023rd, you're thinking it's this one, but it's actually this one. Okay, then what does that mean? This is the O right here, and then we've got E's on either side of it. E, O, E. That is the answer. Sorry if you got trapped on that one. It was a really good one if you weren't paying attention. On to the next problem, guys. All right, the last problem of the set for 10A, and if you're watching this one on the 12A, there'll be one more after this, of course. I do 5 at a time usually. So 2021 AMC 10A problem 10. Which of the following is equivalent to all of this? This is, again, your experience comes to your aid. There were several times in past contests, or maybe in volume 1, where this should look really familiar, right? Let's just take like this part right here, for instance. If I call that x and y, right? Let's say it's x plus y, and you've got x squared plus y squared. Well, if you've ever broken down difference of squares with a really large power of 2, like let's say you had x to the fourth minus y to the fourth, okay? If you did it quickly, which you probably have if you did it in a competition, you would do something like this. You would get x squared plus y squared times x squared minus y squared, but you wouldn't write x squared minus y squared because you're thinking ahead and you recognize that what you're about to write is still the difference of squares. So you write x plus y, x minus y. Interesting. So this looks a lot like that. If I just multiplied it by x minus y, it would look like this. Okay, well what if I had it one more step higher? What if I had x to the 8th minus y to the 8th? It looks exactly like this. It's x to the 4th plus y to the 4th. Again, the other term would be x to the 4th minus y to the 4th, which is this, which means it would just keep getting written. And so the last thing you would have is this x minus y. Well, that means all we're missing is an x minus y term. So let's set all of this, right, that whole expression equal to a. Okay, all of that equal to, I'm not going to rewrite it. We would need to multiply both sides of that expression and the other side by x minus y. Okay, so then how am I going to get it? Well, all of this times all of those things, right? It would just wrap back up to this. Okay, now notice that this is the 8s are not your numbers in the parentheses, which means we're looking at these 64s, then the number that we would write that it's equal to is not 64, but twice that amount, right? It's going 1, 2, 4, 8. So we've got 1, 2, 4, 8, 16, 32, 64. It will be 128 after these all combine. It would be x to the 128th minus y to the 128th equals a over a times x minus y. Now, a is the answer, not answer choice A, but just A for answer, right? In order to find what it's equivalent to, we're going to have to divide by x minus y. So our answer needs to be looking something like this, x minus y. Okay, well, we don't have anything like that. So what do? Well, what was x and y again? It was 2 and 3. And we could try to do algebra on this, but if we just go back to what x and y were, I thought of it originally as x is 2 and y is 3. That's going to give you a negative, but why? Why not x is 3 and y is 2? All that would do is reverse the order of all of these, right? 3 squared plus 2 squared, and they're all pluses, so you can do that. That would mean that x minus y is now 1, and really you're going to have 3 to the 128th minus 2 to the 128th. That is answer choice C. This is why I say to solve all of the past competitions, because if you have, you've likely encountered something like this somewhere along the way. Also, the AOPS books in Volume 1 has something like this when you're distributing, and there's several other ones that do also. So that's it for this set. See you for the next problem on problem 10. If you're watching from the 10A, get ready for the next 5. All right, so here we are on the 2021 AMC 10A. It's problem 12. If you're on the 12A, it's the last problem of your rapid fire set. 2 right circular cones facing down as shown in the figure. Sorry about the drawing skills. Below contain the same amount of liquid. Okay, so in other words, the volume of the liquid cone, if you will, is equal. We don't have to know the cone itself, but the volume of water inside is also a cone, and those volumes of water will be equal. The radii of the tops of the liquid surfaces are 3 and 6, so 3 here, 6 right here. Into each cone, let's just pause right there. Let's figure out some more information before we read any farther. If the volume of a cone is 1/3 pi r squared h, so then for us, the volume of the first cone will equal 1/3 pi, our r is 3. And so we'll have 3 squared, and I will call that h2, I guess. And then, yeah, or h1, we're doing h1. I don't know why I put h2. Okay, so h1. then volume 2 is going to equal 1/3 pi times its radius, which is 6 squared. But the height's not the same. It's height 2. But these are equal. So because they're equal, we can divide out the 1/3 pi on both. It doesn't play a role. This is going to be 9h1 equals 36h2. So I can divide by 9 to get that the first height is 4 times the second height. Okay, now, did they tell us what the volume was of the liquid? No. So guess what that means? We can make it whatever we want because we're looking ultimately for a ratio. I'm going to see it in a minute. What is the ratio of the rise of the liquid level in the narrow cone to the rise? Okay, we'll get there in a moment. But, short summary, we can make H2 1. So this height right here, I'm going to make it 1, and then this height here would be 4. It doesn't matter what it actually is because it's all going to wash out in the ratio in the end. And because they didn't tell us the volume of the liquid anyway. So any volume would have to work, otherwise the problem would be invalid. Okay, so where were we? Into each cone is dropped a spherical marble of radius 1, okay, which sinks to the bottom and is completely submerged without spilling any liquid. What is the ratio of the rise of the liquid, right? You drop something into water, the water level rises. They want the ratio of the rise of the liquid level in the narrow cone, this one, to the rise of the liquid level in the wide cone. Well, it's probably not too uncommon knowledge that the volume of the stone or marble that you put inside is what's added to the volume of the water now, the apparent volume of the water, right? And so our previous volume, now that we've assumed the height is 4, our volume 1 will be 1/3 pi times 3 squared times 4. Or it would be 9/3 is 3 times 4 is 12 pi. Okay, so 12 pi is our volume 1. And to that volume, we're going to add a marble with radius 1. Now the volume of a sphere, which is what a marble is 4/3 pi r cubed. Take the derivative of that. Tell me what you get. Anyhow, moving on, 4/3 pi r cubed, and you're going to plug in 1 to this, because it's the radius of the marble. That means the marble's volume is 4/3 pi. We're going to combine that with the 12 pi. So I've got 12 pi plus 4/3 pi. Let's make this into something over 3. 36/3 plus 4/3 will be 40/3 pi. Now, this is the volume, the apparent volume that the water is taking up now when you add the marble to it. So it's going to have a new height. And we can take the new height, subtract the old height, that will be the rise. So then, let's set this equal to a cone's volume again. It's 1/3 pi. Interesting. 1/3 pi r squared h. Yeah. 1/3 pi r squared h. And so why is the r not 3 anymore? Because it went up. And when it went up, the surface of the water went up higher, so the radius is now different than what it was. So what we would have is that whatever the radius is, it's 3/4 of the height. So I could make this radius here will be 3/4 of the new height. And so that's going to be 3/4 h squared times that height. So the pi's will cancel, the 3's will cancel. I'm going to get 40 equals 9/16 h cubed. I will then multiply by 16/9 times 40 equals h cubed. And we need to find out what the new height is and then subtract 4. So I need the cube root of this. Yeah, kind of not fun. Let's see. So we're going to have 16 times 4 is 64 times 10/9. I'm going to keep the 64 separate. So when we cube root, we're going to have 4 cube root of 10/9. So it's 4 cube root of 10 over 9. Don't bother rationalizing anything. It doesn't really matter. From that, we are going to subtract 4 cube root of 10 ninths minus the 4 original height that we had. So we subtract 4. This is the rise in the water level, okay? And then, oh, it's 3/4 of the height. Yeah, we did that right. Okay, so it was 9/16. We multiplied by the reciprocal, just making sure. Okay, so then this is the rise in the first one's height. Now, the second one's height, it's going to be the volume 2. It also had the same volume, actually, right? And so when you added the marble, it's the exact same new volume, if you will. So it's 40 over 3 pi as well. And you're going to have 40 over 3 pi, and it's going to equal 1/3 pi r squared h. But again, our r this time is a 6-to-1 ratio with the height. So we're actually going to have to replace this r with 6 times the new height, whatever the new height is. So 6 times the new height squared times h. Again, that's just the r squared h, where we see the ratio of 6-to-1 is the radius to the height. It's going to maintain that ratio throughout because of similar triangles. So this h over here, you can call it h2 if you want. I suppose we don't really need to because it's fine though. If you want to call it h2, no problem. Okay. So now we'll solve for h2. We're going to get rid of the 1/3 and the pi. Again, we're going to divide by 36. So we're going to get 40 over 36 is equal to h cubed, h2 cubed. Okay, then what? 40 over 36, we have to cube root that. So we have to cube root it, and then we have to subtract 4. So we're going to have the cube root of, let's do this, simplify this. 40 over 36 is 10 over 9, right? So you have the cube root of 10 over 9 minus the original height, which was 1. So cube root of 10 over 9 minus 1. And now you're going to put that here. I'm running out of board space, but let's just erase this and use this spot right here. So if I divide, it's going to be cube root of 10 over 9 minus 1. And now you will factor out the 4, and it will cancel the cube root of 10 over 9 minus 1 over the cube root of 10 over 9 minus 1. The ratio you get is 4-to-1. Now we know this is the narrow cone because that's the one that we used first. So we get a 4-to-1 answer, answer choice E. Quite a difficult problem. It's really starting to get hard on the AMC 10 and the AMC 12. We're getting close to qualifying. That's probably why. On to the next problem.